So as Chandralekha mentioned, I'm Melanie Good, and I'm here today to share my third talk about the course transformation I implemented last fall in 2019, which was the last normal semester that we had in person completely before all of this pandemic hit. And because of all of those COVID interruptions, it's been some time since my last presentation. So I want to start by recapping the rationale for the transformation and what was done before I start talking about the results. So just to refresh our memories, this course transformation applied to the Basic Physics 1 class, which is an introductory level physics class taken by engineering majors, computer science majors, mathematics majors, chemistry majors, and a few physics majors as well. Typically, they take this in their freshman year. And so, you know, since this is kind of a gateway to more upper level classes, it's important that we engage these students to the highest degree possible. So I set about trying to improve the level of engagement in the basic physics class. So the question becomes, how do you actually measure student engagement? And I incorporated a couple different measures into the course transformation. One was to use a validated survey called the Attitudes and Approaches to Problem Solving Survey, which measures your attitudes towards physics problem solving compared to an expert-like response. And in addition to that, I also customized some questions on my OMETs in order to target the question of engagement and see if I could probe how the engagement level was through the OMETs. So last time I presented some preliminary results about both of these measures, but this time I'm going to go into a lot more detail about it. But before I get to those things, just to recap what the rationale was behind the course transformation and what was actually done. In previous research, I was able to find that introductory physics students on average at the University of Pittsburgh score higher on the AAPS survey compared to introductory astronomy students, that is, score higher on average than introductory physics students. And when I conducted student interviews, and especially with students who had taken both the introductory astronomy class and the introductory physics class, I was able to uncover some reasons that they identified for why they found introductory astronomy to be so engaging. Some of the things that were identified were the tangible kind of images that were used in instruction. So you'd see a real image of a star or a galaxy as opposed to some abstract cartoon like you often see in a physics class. In addition to that, instruction often incorporated discussion about current discoveries, so it felt fresh and new to them. And also when they're solving their problems, they're doing it in a context that seems very interesting. You're solving a physics problem, but really it's about space. And so that the students found that to be especially interesting. So it got me thinking, is there a way that we can incorporate these ingredients into the introductory physics class and improve the engagement and bring it more in line with the astronomy scores? And so why not, instead of using abstract cartoons, use some more real imagery instead, realistic representations, realistic problems, incorporate newsworthy events into instruction. And if it's possible to solve a physics problem in an astronomy context, why not bring that into the introductory physics experience? And so in order to incorporate these ideas into the instruction, I devised a three-pronged approach where I looked at not only the lecture, but also the homework and the recitation, and set about trying to bring these things into, incorporate these ideas into each of these three things. So in the lecture, I look to include more real imagery and discussion about current newsworthy events and discoveries, and also to use an astronomical example if it's possible. and then in homework, you know, instead of the typical textbook problems that you often get with the online systems that tend to be kind of dry, try to make them more realistic and engaging. And likewise, in the recitation, make sure that the kinds of problems that they're working through are also realistic and engaging. So, for example, in the homework, rather than rely on a specific homework system, I created each assignment in, well, in those days it was Blackboard. These days you could probably do something similar in Canvas, but I incorporated the assignments directly into CourseWeb, where the students were sometimes asked to engage with interactive video vignettes or simulations, or otherwise give open-ended responses, and maybe also some select textbook questions that are particularly realistic and or involve an astronomy context. And then in the recitation, rather than, you know, a dry kind of question or a quiz, we engage the students in a group problem-solving effort where the students were solving context-rich problems. And these are problems that are designed to have a realistic context. And they demand a more systematic approach out of the students because the problems themselves are often ill-formed, and the student has to formulate both the problem and then the solution. So a systematic approach will be more successful in that regard.
Melanie, can you give an example of what might be a context?
Yeah, so I took this slide out from my last talk, but, you know, so and one example was, you know, you are whirling a bucket of water and the string breaks at some point, and you want to know what the tension was in the string and how it broke, and you wouldn't necessarily state the question there. You would just say, well, you know, what kind of string do I need? And put it more like a statement that they have to figure out what it is that they're trying to solve for before they actually start implementing the concepts and the equations. And then in the lecture experience, I try to kind of revamp the demos that I typically do and provide a more engaging and interactive experience. You know, it's one thing to just show something happening, but to actually engage the students and get them talking to each other and answering questions about what they see and making predictions about what they see was what I wanted to do with the demos. And then also, whenever I'm presenting my slides, try to use the real images rather than the cartoons that you often see. And incidentally, I tried also in those real images to be sensitive to diversity and representation and not just include, you know, the stereotypical white man doing a video of a certain thing. So, you know, I tried to include diversity of images as well as, you know, real life videos and images. And then also to connect it to current newsworthy events. So, for example, I think the first female spacewalk had been done that semester. And so we discussed that briefly, and it was nice in that it segued neatly into what we were talking about gravity and orbits at that time. And then that goes along with incorporating astronomy context whenever possible. So, you know, if there's a problem about centripetal force, why not try to do that with planetary motion and not just, you know, whirling of a ball on a string. So so to present some of the results, last time I did talk about the overall AAPS score. So I want to review that and then go in a little bit more detail with it. So the AAPS survey, as I mentioned before, was validated. It consists of 33 statements that you can choose to agree or disagree with. And on this particular plot, this is from historic data, the vertical axis indicates the level of expert-like response. So a 1 would indicate an expert-like response, whereas a negative one would capture a novice-like response. So 0 is somewhat neutral. And you can see here that the physics on average is lower than the astronomy, and that's what I had mentioned that I had uncovered in previous research. So the goal was
Melanie, could you please give some examples of the questions from the AAPS survey?
Sure. So some of the questions on the AAPS survey are statements like, in the problem-solving process, I always identify the physics principles involved in the problem first before looking for corresponding equations. And another one might be, if I solve two different problems two different approaches to solve a physics problem and they gave different answers, I would spend considerable time thinking about which approach is more reasonable. So, you know, they get at your problem solving approach. There's also statements about enjoyment of the problem solving process and reflection on the problem solving process. And the people who respond to this can choose to agree, be neutral, or disagree. And then we capture that with this scoring system where and it might flip, like the expert-like response might be to agree on one statement and then disagree on another statement. But we account for that, and if you've given an expert-like response, you get a score of 1 on that question. If you've given a novice-like response, then it's -1, and neutral is a 0. And then you take the average over all 33 of these questions. And so you can see that the physics students on average are scoring lower than the astronomy students. And this is why my goal was to try and bring this average AAPS score more in line with the astronomy score. Of course, I'm not hoping to get it to the level of graduate students or faculty, but for an introductory class, it would be nice to see it improve to the level that astronomy is at. And what I presented last time was that, unfortunately, although I did see some improvement in the overall score on the AAPS in the transformed class, this was not statistically significant. So, you know, it wasn't quite to the level that I had been hoping. However, that being said, I want to look at a subset of these questions on the AAPS survey that I did find more promising results in. So in previous research, a factor analysis was conducted by Andy Mason, in which he identified subsets of questions that are correlated with each other and explain the percentages of variance in scores in order to identify themes that account for this variance. And one very important theme that came about from this factor analysis and that I examined in my research with this transformation was the theme of metacognition and enjoyment of problem solving. And so this particular factor, this theme, factor 1, involves 12 of the 33 questions. And these are questions that get at whether the student is metacognating and enjoying the problem-solving process. So I've given a table here that sort of summarizes really briefly what the statements are. I don't have the full statements written out for each of these questions, but you can see that they probe themes like reflecting on your answer, troubleshooting, enjoying the problem-solving process, using different principles and applying them to different problems and so on. And so to me, this particular factor really uncovers whether or not the students are engaged in the problem-solving process. Are they reflecting? Are they enjoying? And so to me, this is a good measure of engagement. And you can see here that the transform scores, which I bolded each one that is higher than the physics scores historically, almost all of the questions the transformed physics class scored higher on. And so when I take the average of that particular factor, factor 1, you can see that the transformed class does score higher on average in that particular factor about metacognition and enjoyment of problem-solving process. And even though the overall AAPS score was not a statistically significant improvement, it was a statistically significant improvement in this particular factor. So to me, this is a promising result. In addition to this, I also just looked at some other individual questions to see if there were ones that I saw any other interesting patterns with. And my attention was drawn to question number 26. In question 26, it says that it's more useful to me to solve a few difficult problems using a systematic approach and learn from them rather than solving many similar easy problems one after another. So again, this question to me is getting at the question of their level of engagement. Are you willing to take on a more challenging problem and engage with a more challenging problem for the sake of learning than just sort of taking the easy way out and doing easier problems? And so on this particular question, Transform class actually scored not only higher than the historic physics class, but also higher than the astronomy historically as well. Now the difference between the transformed physics class and the astronomy class on this question was not statistically significantly different, although it was a little bit higher. But the difference between the physics class and the transformed class is clearly statistically significantly higher by a good measure. So to me, again, this is a promising result that there is some suggestion that the engagement of the students in the transformed class benefited. And so then the takeaway I would say here was that while the overall AAPS score did not significantly improve statistically, there were some important aspects where I did see improvement. In particular, when it comes to metacognition and enjoyment and the systematic approach and willingness to take on difficult problems, there's a suggestion that the students have improved in a statistically significant way. So that takes me to my other measure of engagement, and this was the targeted OMET questions. So last time I did mention what these questions were that I incorporated into my OMETs. But to recap, I put statements about the use of real-life images in lecture, whether or not the demos were beneficial, the simulations and video clips in homework, and also the real-life questions in homework, and also the question about whether the real-life kind of questions in recitation contributed to the engagement of the student. And I think last time I gave you a little bit of a synopsis, a preliminary result, that it looked like the majority of students agreed with all of these statements. But I want to go through them one by one and discuss the details about these targeted OMET questions. So with regard to the real-life imagery and the real-life questions, both in lecture and in homework, and also in recitation, so in all three prongs, there was the majority of students who agreed with these statements that these things were beneficial to their learning. In particular, the lecture was a very strong consensus that the real-life images, they found these to be engaging. The homework was a little bit less of a consensus, but still the majority, and the recitation was also a majority, but less of a consensus as well. With the simulations and demos, these were very popular. The simulations had a strong consensus that they were beneficial to the learning. With the demos, not only was this the strongest consensus that I saw, but this was a common theme that arose in the open-ended responses to the OMETs as well. When I started looking through what students had quoted in the open-ended responses, I was seeing things like the quote that you're seeing here, which I guess I'm going to move these aside so I can actually see it. I like how she would explain her class with specific examples and bring in demos that were fun and productive for the class. So I like this quote because it got not only at the fact that they were beneficial to the learning, but they were also fun for the student. And this was a common theme that I saw arising when I started looking through the open-ended responses, that the demos by far seem to be the most popular aspect, the way in which that I tried to really make them an interactive experience. The takeaways, I would say, from the OMETs then are that the majority of the students agreed with the statements that I put in the OMETs about engagement, and that out of all three prongs here, it appeared to me that the lecture portion of the prong was the most successful aspect, because in those OMET questions, the vast majority of people found the demos to be especially beneficial. Out of the real life image or real life question targeted OMET statements, the highest majority of students agreed with the real life images in the lecture portion. And the homework was also successful, perhaps to a lesser degree, but the simulations were very popular that I incorporated into the homework assignments. And the recitation was also successful in that students agreed with the statements about engagement there. But you know, these sort of go in the order of how much direct control I have over them. The lecture is obviously the thing that I have the most direct control over, and that was seemingly the most successful in terms of what the students were telling me in the OMETs. The homework I have a little bit less control over because it's something they do in their own time. And the recitation is the thing I have the least control over, since it's something that is conducted by TAs. Although, you know, I did meet with my TAs on a weekly basis and try to make sure they understand the importance of these context-rich problems and how to make them realistic and an engaging experience. But it's still a little bit less direct. So I think for me, the takeaway was that you know, the thing that I had the most direct control over was the most successful aspect. So that was heartening to see. So in conclusion, I guess what I would say is that if I am measuring the success of this transformation in terms of engagement by both of the measures, the AAPS and the targeted OMET questions, I'm seeing signs of success that there was an improvement in engagement. There's obviously room for further improvement, and I didn't really get into it this talk. I had mentioned it in the last talk, that there were some technical issues that I encountered, and of course those technical issues are now even more salient now that we're in a remotely instructed situation. So when I'm moving forward and looking to improve my results and address those challenges, that's something to bear in mind. As everyone's aware, you know, we've moved, our technology has had to change, and we've moved to Canvas on top of that, and we're dealing mainly in remotely instructed classes. I heard Michael saying that he is still doing some in-person instruction at the beginning before we started, but I don't know that all of us are doing in-person instruction, or that can be done in all situations, and it's hard to say what will happen in the next semester. So for now, my framework is that I'm still thinking about how can we go further, given that we have this technology that we may need to be wrestling with. So for me, one of the pressing questions then is, you know, the students found the demos to be highly beneficial. How do you translate that into a remote situation? And so this semester, although I'm not teaching the basic physics class, I'm teaching the other introductory level physics class. And one of the things that I'm trying to do is pair the PhET app with discussion boards in order to sort of replicate more simulations and also replicate the demos to a certain degree as well, where we can actually discuss and engage with the simulations that way. In the lectures, it's difficult because everybody's behind a screen and you can only see so many faces at once. So I've tried to incorporate participation credit, and one of the ways that they can earn participation credit is through the chat. Thanks, Danny, for providing the FET link there. If anyone's unfamiliar, these are, Danny put a link in the chat, and these are simulations that not only include physics simulations, but there's also mathematics and chemistry and a couple other different things there that you can interact with. And you know, the kinds of questions that I would ask them in the discussion board were to interact with the simulation and then discuss their results, or what was surprising about it, or include a screen cap of, you know, if they've designed a skateboard ramp in such a way that there's, you know, a potential well here and then a smaller potential well here, and discuss how the skateboard, whether the skateboard's mass matters and things like that. So getting back to the idea of lecture and participation, so I'm trying to, it's difficult because I know that some students may be either choosing to or unable to attend live, although I'm trying to really press for them to do that in a remote situation and earn participation credit by completing things in the chat or verbally in lecture. But it's definitely a challenge. The homework system is now different if I'm going to stick with CourseWeb moving forward, because we no longer have Blackboard. And in Blackboard, you know, I had a lot of images. Real images was important to the course transformation. And I don't know how many of you have encountered this, but in Canvas, images do not always display for students. It's an ongoing issue. Sometimes it has to do with the student browser, but it also seems to be an issue that pops up randomly that, you know, I haven't been able to fully troubleshoot. And then there's the question about how to conduct assessments in a remote situation and other technical matters that the students may encounter. I found that having a frequently asked questions page in Canvas has been helpful for students and helpful for me too, so that if students do ask a frequently asked question, I can even turn them to that so that they can find the answer to that question. And sometimes it has to do with technology, but other times it just has to do with regular questions they might have otherwise, but it increases the communication. You know, they can't just drop by my office necessarily. So having a frequently asked questions page helps for that sort of spontaneous question that they might have. And I'm still wrestling with how to do assessment in the best way. So, you know, trying to improve upon the results, given that we are in a remote instruction situation. And that's how I intend to teach the basic physics class next semester. We were asked about, you know, are we doing this in person? And I wasn't comfortable with the idea of in-person instruction at this point. Maybe that'll change. It would be nice if it changes, but you know, my default is to think about remote instruction. So one of the things I'm trying with the algebra-based students, and I'm trying several different things and hopefully seeing if these can be then incorporated into the basic physics next semester. Rather than doing a final exam, I'm doing a capstone project with them. And I'm hoping that this will increase engagement in that it involves hands-on activities, problems, and experiments that they are asked to design themselves. In addition, I started making use of the study groups in Canvas to try to incorporate better group dynamics and engage the students that way. Canvas has the ability for students to choose different study groups, or you can put them in randomly into study groups. And I've incorporated some time for them to actually study in study groups as well. And then
how is that working out, Melanie?
Well, some students were reluctant to work in the study groups, quite frankly. They wanted to kind of be on their own. But the ones that I have seen, that I have talked to, say in virtual office hours, they have reported to me that having the study groups was useful for them because it gave them a way to kind of break the ice and say, okay, I've joined the study group. Now I have a reason to reach out to this student. Now I have a reason to, you know, try and work together with this student, whereas, you know, I may not have known who to contact or what to say otherwise. And then I'm trying to segue those study groups into a group portion of the final capstone project where they work within their study group on, and at least not the entire project, but part of the project is a group response. So that gives them a further reason to try and work together.
So you're saying that this is something that you're trying right now. So what's the are you doing random assignment of these groups, and how many people are there in each group?
Yeah, so I started by allowing them to sign up for their own study group because I thought that maybe there would be students who knew one another and may already have a relationship with one another. And so, they could just choose to work together if they wanted to. Or they could just sign up for a group randomly if they wanted. Then once it got to a point where I saw that, this many still had not signed up, then I just randomly assigned the rest to study groups. The number, I capped it at 5 in a study group. I think that's higher than I would in person, but this is just kind of based on, trying to get a critical number in a Zoom world where, there's at least some discussion. And also because I'm teaching the algebra-based class this semester, the numbers are higher. So, I'm dealing with a class of 230. So I was worried about having groups too small and then just having so many groups. So I capped it at 5 right now.
So how many students actually signed up on their own without you actually doing any assignment? What fraction? Like, was it 20% or?
No. It was more than half of the class.
Wow.
I don't remember the exact percentage, but when I looked to see how many I had to randomly assign, I believe it was less than 100. And, there's 230 in the class. So yeah, it was more than half that chose to sign up on their own.
Mm-hmm.
And
I
so,
wonder whether there was like, it was diverse automatically in terms of, men, women, racial, ethnic minority students, majority students, and how it worked out in the end.
Yeah, I didn't actually look through that carefully to see what the makeup was of each group. And so, I guess I do need to think about that moving forward, how I want to set up the groups. I think it's a good idea to have these study groups, but maybe I should think about tweaking the number or who all is in each group. I think that's particularly important for the basic physics class that I'll be teaching next semester, 174, compared to 110 that I'm teaching this semester, because 110, 111 have a little bit more diversity to begin with. Whereas, in 174, you have a lot less diversity. And so I think it is important to pay attention to group dynamics there. So maybe I can incorporate a little more oversight into the assigning of groups next semester.
And these things they are doing at their own time, so the timing needs to work out for different people too, right?
Right. And in fact, that is in itself a difficult thing because, I have a student in China. I have a student, they're scattered all about in different time zones. And so, it does make it difficult, not only for me I don't feel that I can demand that everybody attend a live session if it's happening in the middle of the night for a student, for example. But also within a group, trying to find somebody who's on the same time zone as you and who has a similar schedule, it is a little difficult to overcome. But I'm trying to keep the lines of communication open, and that's my final point here, is that, try to reduce the stress level that they're facing during this pandemic situation, and, encourage persistence, encourage communication. That was part of the rationale for having a frequently asked question page. I've mentioned to the students too that I try to tout the good things about this remote instruction situation, that, you know, yeah, it has a lot of drawbacks, but there are maybe some things that are actually better. Like, for example, if it's in the middle of a lecture and you want to ask me a question, but you're afraid to ask, you know, you can always privately chat something to me. And I do try to pay careful attention to the chat as we go. And students are chatting a lot, actually, to the point where I have to wait until, you know, maybe several questions before, otherwise I'd be stopping every couple minutes, you know, so I usually wait till there's a few questions and then I'll address the chat. But, you know, the private chat is a way to communicate and engage with the instructor, even if you're feeling a little intimidated to say something. So, you know, I'm trying to remind them of these things, and I'm trying to be flexible. Like I said, with the synchronous versus asynchronous participation, I've given them many ways of earning their participation points. They can, you know, talk in the discussion board, they can talk into the chat. The discussion board can be asynchronous. I've also, I'm joining there's an app, I think David Nero has it this semester as well, called Course Mirror, where students can submit reflections. And that's another way I'm giving them an opportunity to earn participation points, and that's asynchronous as well. So, you know, I think it's really important to keep the lines of communication open from the beginning and encourage that kind of participation from the beginning if we're trying to move forward and engage students. But, you know, if anyone has further ideas or suggestions, I'm definitely open to hearing them. And, you know,
Melanie, I was wondering if you have any undergraduate TAs in your class, because I mean, you know, they could also help you in monitoring the chat and things like that if you feel like you're getting distracted by, you know, too many things at the
yeah,
same time.
yeah, I do have a couple undergraduate TAs in both of my classes this semester, and I actually did ask them about monitoring the chat. And we tried it for a while, and I found it wasn't necessarily as helpful as I thought it would be. But you know, they are trying to help the student participation in different ways and keep track of the student participation for me. So I do have them working on that. It's just
But
not.
what aspect of it was not helpful? I mean, like, was there a good plan ahead of time as to when they are going to tell you what the questions were or something?
Well, part of the thing was that availability of the UTAs. Sometimes they weren't always available every lecture. So then I wasn't always able to keep track of who was there and available and who wasn't, and whether or not I needed to pay careful attention to the chat or not. Also, because they're undergraduates, sometimes the level of question, they may not necessarily know whether it's a pressing question to answer. Like I'm saying, I'll wait till a few questions build up. But if I see in the chat that somebody has a very wrong idea, you know, I try to address it really quickly, because I don't want there to be like some fundamental misunderstanding being propagated in the chat. So, you know, another undergraduate student may not realize how crucial that might be, or time sensitive that might be, or maybe they're feeling intimidated to interrupt. I'm not really sure, but you know, sometimes I was getting the sense that they were just waiting for X number of questions without a good sense of, okay, but this question probably should be addressed right away, if that makes sense.
Yeah, I mean, I think that, you know, it depends upon how it works out for you, because some other instructors say that they don't want to look at chat at the same time that they are also lecturing. But I think it looks like overall it's working out okay for you, right?
Yeah, actually, I was really worried about trying to monitor both things at the same time, but I'm finding that as you practice it, it becomes easier to do, and that when I was in person, I would naturally take pauses. We would all, I'm sure all of us naturally take pauses to say, okay, is everybody on board here? You know, does anybody have any questions? And usually during those natural pauses, I take a second to just kind of scroll back in the chat and make sure that nobody has any outstanding questions. So it's sort of just a natural extension of that. So for me, it's worked out. There is participation. I've been able to monitor it. So, you know, I could maybe rethink about how to involve the undergraduate TAs in a better way. I think that maybe some of them are also afraid to answer a question directly because they're afraid to say something wrong. But I don't know. So anyway, that basically is all I had to say today. You know, I wanted to thank everybody that was involved in this transformation. But if people have further questions or want to talk or add suggestions, I'm more than happy to hear.
Thank you, Melanie. All right,
Thanks.
so questions, comments, you know, feedback to Melanie about what can be done better, or, you know, anything that was not clear to you. Please just unmute yourself and ask her.
Hi, Dave here.
Hi.
So I feel like you're selling yourself short with what you've done in physics. And I think perhaps that's because the AAPS might not be the best tool for measuring what you've done in the class. You know, I think a lot of your changes, like making it more applicable to the students in more real world than line drawings, I mean, that may beneficially impact how they approach physics, but it might not change their strategy for problem solving, which is what the AAPS is going to measure.
Yeah, well, the APS it is complicated because it, you know, it measures, you're right, it measures their strategy and approaches, but it also measures their attitude. So, and sometimes it mixes both of those things within a single statement. So did you have another measure that you had in mind to try to measure these things?
You know, almost maybe a CLAS sort of thing.
Mm-hmm.
Or your own questions along the lines of CLAS. I mean, of course, if it's like a vetted survey, that's going to be a lot more convincing than something you come up with.
Right, right.
I mean, I guess what gets me thinking is it's like your main goal here was an astronomy class or astronomy classes in general. But like which astronomy class? Like to have problem solving, that would have to be something like the equivalent of our astronomy 113.
Yeah, and that's what it was actually. The data that I showed you earlier was the 113 students taken over. I think it was taken over many sections in many semesters. So, you know, there were a fair number involved that are doing, you know, basically analogous level difficulty in terms of problem solving.
Yeah, but the target audience is different. I mean, so this is like a post survey. This isn't a pre-post, right?
Right.
So you don't know what the attitudes were starting the class. I mean, it may be that students who take astronomy 113 have different attitudes initially than students who take, I guess it was 174.
Yeah,
physics.
yeah. I mean, that's possible. I did look at pre and post with a different set of data that wasn't at University of Pittsburgh, and there does tend to be a decline in how they perform on the AAPS. I would think that would be applicable to Pitt as well, because we also saw that trend at two different other universities that are similar. But that was only done with physics students. So you're right, it wasn't really done pre and post with astronomy.
Yeah, for physics students overall, it definitely goes down. Their attitudes and approaches to physics problem solving after instruction is worse than what they said at the beginning.
I've heard about the attitudes declining on CLAS. I had not heard about problem solving strategy declining.
That's problem solving,
concerning.
again, notice that this is their own self-evaluation of what they are doing, right? So they are saying that I'm using more plug and chug in this class at the end of the course than they were at the beginning of the course. They're reflecting less at the end than at the beginning, that kind of thing.
Specifically on the AAPS?
Yes, because as Melanie said, that we haven't done pre and post in astronomy context, but we have for physics context. And it definitely goes down at the end of the semester in physics compared to at the beginning. So students are less reflective about problem solving at the end than what they had anticipated to do at the beginning. They are less, thinking about what is given, where they are going, breaking the problem into sub-problem and stuff than what they had anticipated at the beginning. So I think in that sense, overall, it's definitely going down. For physics major, not physics majors, but physics courses, introductory physics students.
Right.
So from high school to finishing first semester?
Right. And this is something that Melanie herself had done.
Yeah. And I mean, there were some exceptions to this with gender. I had found that female students, for example, do not exhibit the same kind of decline as male students. But on average, from pre to post, it does decline for the physics students. But you're right, I don't have the astronomy to compare to that. So I don't know necessarily if there was a similar decline with astronomy students or not. I would wager that there might be, but it's hard to say.
Yeah, that was an interesting thing, that what Melanie found is that women were not declining in terms of, their attitudes and approaches to problem solving from the beginning to the end of the semester, where men were really going down. And one hypothesis that we had was that perhaps the fact that women have also lower self-efficacy about solving physics problems and things, they were being more careful and they were using more, deliberate strategies, and they were actually being more reflective in physics problem solving throughout, whereas men were more likely to go to plug and chug approaches as the course progressed. So that's what she was finding.
Yeah.
That's interesting.
So,
but yet your graduates, they're back up.
And
towards
actually
experts again. So something changes along the way. There's
there's
some inflection point.
There is.
Sorry, say again, David, what did you say?
Well, there must be some inflection point because the graduates are up, and of course the faculty will necessarily score high on this kind of assessment.
Right. Sorry, Melanie, what were you saying?
Oh, sorry.
Oh, I was agreeing with you that it does improve again. It's not the end of the story, right? Because even going from physics 1 to physics 2, there's a bump up in what the average score is. So somehow it changes. I don't know. I don't know beyond that. It's not like we have junior level classes we've looked at. So.
Yeah.
Other questions, comments for Melanie? Please unmute yourself. Please unmute yourself.
Hi, question. Melanie, what do you get your UTAs to do again?
So they are helping me keep track of participation at this point. And also they're holding office hours. Those are the main things that I'm asking them to do right now. But, I originally envisioned having them sort of in real time monitor the chat and, let me know when there were X number of questions, or let me know when there was a particularly pertinent question. But in practice, that was a little bit difficult to actually get working. Did you have suggestions for how to involve them in a more productive way?
I don't know. Okay, so my UTA has been tasked to do it, basically do that, and I feel like she's been doing a really good job at monitoring the chat. And I've encouraged her. Actually, she was a bit hesitant to basically speak out whenever she felt there was a question, and then from time to time, she'll also just directly answer them in the chat because there were a few topics that she was comfortable enough to do. And the topics she wasn't comfortable, she would just say, ask the question, or be like, oh, there's a question in the chat about X, Y, Z.
Yeah. Okay. Well, so maybe I should try encouraging that more.
She's also in every class. So I thought UTAs have to attend every class.
Well, I think it depends upon the instructor.
Yeah, and it's also, I personally just felt a little unsure of what to demand, because of the flex situation where, you know, there may be students in different places, and, you know, I wasn't sure if I was within my rights, so to speak, to say you have to be there
For the
synchronous.
UTAs?
Yeah,
Yeah.
I think it's up to the instructor, you know.
Okay, I thought it's in the contract that UTAs have to attend every class, and it's
They
online
should,
anyway.
they should. I mean, the thing says that they should, but again, if the instructor doesn't insist on it,
Okay.
sometimes they don't. So I think that it's really up to the instructor to insist on it or not.
Yeah, and I mean, that's something I probably should revisit. I guess, you know, because students are attending asynchronously, does it count as attending if they're just watching my recordings? You know, I don't, to me, it's a little ill-defined, but
Oh,
I
I
guess
was talking about the UTA specifically, the UTA, because I thought you said they weren't always in class or something like that, which was
yeah, I mean,
weird.
I remember that at the beginning of the semester, one of them asked me and said, you know, I have a conflict with this day, but not that day. Is that okay? You know, and then I was like, sure. And then the other UTA could do the other day, but you know, it was just, I was finding it difficult to keep track of. So, but, you know, it may be worth revisiting that and saying, you know, if you want to be my UTA, you kind of have to be there. You're finding this monitoring of the chat to be beneficial, Roger? Like, how did you encourage the UTA to kind of get over her reluctance to say something?
I don't know. I just gave her some encouragement. I also make my UTA the co-host, so it automatically shows up at the top. And she's also told me that there's been people private message her also. So there's public chat, there's private message to me or the UTA. And so I just keep them at the top of the co-host. That way everyone can find my UTA very quickly.
Yeah, oh, that's smart.
Yeah, David is saying that he does it too.
Okay. Well, that's good to know, because frankly, that didn't occur to me as a thing to do. So is it easier to chat if you're a co-host?
If you click on the thing in the participant list,
Oh,
you're
I see.
automatically ready to chat with that person, for example.
So they don't have to scroll through and through and through. I see. Or search or remember.
Yeah, it'd be
that
much harder for a 200-person class to be like, go talk to this person.
Yeah. I see what you mean. I wasn't aware of that because I've only, you know, kind of received the private messages. I haven't necessarily unless it's a response. So
yeah, so if you click on a name, automatically private chats to them. If you click on your own name, then it's everybody.
I see. Yeah, I mean, I knew that, but I'm just saying I didn't see how it bumped the co-host up to the top here. I see that now. I'm clicking on the chat now, and I can see that Danny's, you know, right underneath everyone.
So Melanie, I have a question. You know, one of the things that you had said last time is that doing this transformation did not actually change students' scores, like on various things. So their performance was unchanged from previous years. And so can you actually say more about that and what your thoughts are on what you can do to improve that?
So I think to me, in a way, it's no surprise that their content scores wouldn't have necessarily been higher, given that, as David pointed out, you know, this AAPS is looking at how they approach the problem solving, and we didn't see a statistically significant improvement in their overall scores there. So, you know, it's not, to me, a huge surprise, but then again, I did teach this class again over the summer, and I tried to use all of the same sort of materials that I used before, minus the demos. I didn't really have access to the demos, so that was unfortunate. But in the summer class, now granted the N is very small, but in the summer class, I actually did see a little bit of improvement in performance. I probably should have mentioned that, but it wasn't specific to this particular semester, so I didn't include it. On average, the final exam scores were higher over the summer. Now, whether that's actually due to the course transformation or the fact that it was a smaller class, a more intimate class, and I was able to do one-on-one oral exams because of that, I'm not sure if it's exactly comparable.
Yeah, I mean, summer classes are somewhat different. The reason that I was thinking that maybe this kind of transformation would actually lead to better, learning also is because, for example, if you are saying that students are answering questions related to enjoyment and metacognition in physics problem solving much more, I would think that if the students are more reflective, by metacognition, the way I think about it, I'm saying students are being more reflective about problem solving. They are actually thinking much harder, at least that's their view, because obviously they are self-reporting what they're saying. But the point is that the way I view it is they are being more cognizant of what they're doing and they're thinking harder about, reflecting upon these things. So I would have thought that if they're being more, systematic in their approach, then that would help. And maybe similarly to, with respect to enjoyment also, I would have thought that if you enjoy something more, it could potentially show better engagement with that learning, whatever you're learning. And so it could potentially make you more deliberate. So I would have thought that this could actually potentially affect, but I think summer is not a good course to compare with the other ones because summer is a very different kind of student body.
Yeah, I agree. And so that's why I didn't really go into the summer class in this talk, but and I totally agree with you that, you would think that with this metacognition and enjoyment aspect that you would see some improvement, but, maybe it's just not enough of an effect yet. And if I can increase that a little bit more, then maybe it would manifest then in their performance. To me, it is the key, that if you can get that metacognition, if you can get that reflection and deliberate systematic approach, then, that's the key to improved performance. So I think that there's hope that it could result in improved performance. I'm not seeing it yet.
Any last question for Melanie then? Anybody, please unmute yourself. All right, 1, 2, 3. It looks like nobody has a question. Melanie?
Okay.
All right, thank you so much for presenting this, and I'm sure like future iterations of it will be even better. So, good job. Thanks, Melanie. Thanks, everybody. Stay healthy.
Bye, thanks.